Hi everyone, welcome to our webinar today, Heat Pumps Explained What You Need to Know. My name's Joe Dart, I'm editor of HPA magazine, and I'm here with Phil Hurley, who is the chair of the Heat Pump Association. So just before we kind of kick things off, so I want to explain the format for today. Essentially, Phil will be doing a lovely presentation for us first, and then after that, we'll be kind of going into a Q&A session. The idea behind the Q&A session obviously is a chance for you all to ask your questions of Phil, and do please feel free to start asking them while he's doing the presentation, and we'll kind of collate them all at the end. The way you do so is there's a handy Q&A section down the bottom. If you just click on that, you can ask questions from there. And obviously that we will kind of look at all of them as they come through, and aim to get through all of them, but there's an upvote facility, or at least there should be. So obviously we'll probably start with the most popular ones. So yeah, please do kind of get involved and ask questions that way. One question I'm sure a lot of you have is about whether this webinar is going to be recorded or not. It is. It's currently being recorded, and it's going to be published on the HPA YouTube page, and also it will be published on the HPA website, so hppmag.co.uk in due course, hopefully in the next couple of days or so. But I think that's pretty much everything on my end, so I'll probably pass over to Phil at this juncture. So Phil, please do start things off.
Thank you, Joe, and good afternoon, everybody. Thank you for attending this webinar. I'll just quickly share my screen. Hopefully you can all see that. So, yeah, thank you for the opportunity presenting today. Joe said, I'm Phil Hurley. I'm the chair of the Heat Pump Association. And what the presentation I've done today, I've really split it into two parts. So the first part is an overview of policy, why heat pumps, what's happening, how that affects you, and different incentives, training. And then the second part is basically just an overview of heat pumps and what heat pumps are available, and the pros and cons of them. And hopefully from that we'll generate lots of questions for you later so I can answer. So some recent announcements, and I've been a heat pump now 20 years, and really in the last 2 to 3 years, the prominence has really came. And one of the interesting ones is in COVID, and part of the 10-point plan what came out of COVID is Boris Johnson said he wanted to install 600,000 heat pumps by 2028. And that's really being picked up in the national press as heat pumps being a technology to achieve net zero. So
sorry, just to jump in, you're still on the first slide. It's still showing the first slide for you on my one. Technical, yeah.
Is that it?
It's showing the actual PowerPoint presentation. So I don't know, rather than the actual slideshow mode. So you might have to go through manually. Yeah, that you've gone through the slides now. So.
You see that?
Yeah, we're on the white heat pumps.
Oh. Great.
Right,
on recent announcements. Great. Sorry about that. So yeah, so 600,000 heat pumps by 2028, and I mean the UK government is the first government in the world to have an ambitious net zero target of 2050, and the Committee on Climate Change estimated that if we're going to achieve that, we need to be installing around about 1 million by 2030. So 600,000 came out of the blue, and heat pumps are now firmly recognised as a technology, and that really came about in October with the launch of the Heat and Building Strategy, and really a firm commitment of the government of heat pumps as a technology to enable us to decarbonise heat in our homes. And if we're going to achieve these net zero targets, and we have got a climate emergencies, then we can't wait for other technologies to come, okay? And heat pumps is a proven technology which can decarbonise now. It's no silver bullet, okay? There will be a mixture of technologies to achieve net zero, but heat pumps is a technology which can achieve carbon emissions now. One of the big changes this year, you may be aware of, is that the new building regulations comes into force in June this year. One of the main changes in that, which we've been asking for a long time in the heat pump industry, is lower flow temperature. So what will be in that new building regulations is that all heating systems, irrespective of heat source, will be mandated to have a flow temperature no more than 55 degrees, which makes all heating systems efficient, even gas, and it means that gas boilers will be in condensing mode as well. And a big one which has really been missed out is oil and LPG has been committed to phase out in homes by 2026. Initially, it was a target by the end of the 2020s, so 2026 is encouraging. There'll be a consultation this year how they're going to achieve that, but that's real positive to taking high carbon fuels off the gas grid. And there is an ambition, it's not a ban, but there is an ambition to phase gas boilers out by 2035. So really that's what we're working to at the minute. So why heat pumps? Okay, so if you look at this, chart here, it's giving you what the carbon savings are from heat pumps, and the current carbon savings with electric generation, where when we generate electricity at the moment, an air source heat pump will give you about 0.08 emissions, and ground source a little slightly better at 0.07. So compared to an oil boiler, which is 0.28, and a gas boiler, 80% of our homes is 0.2. The thing with our heat pumps, if you put a heat pump in today, it will continue to reduce carbon emissions over time, because what's happening is that the electric generation is decarbonising all the time. So by 2050, it's predicted that an air source heat pump and a ground source will only emit 0.01 kilograms of carbon. So that's a positive for heat pumps as well. So how do we compare to other countries?
Okay, Phil, sorry to jump in again. I think we're still having the same issue. I think it's just what's showing is just the actual presentation on the screen, not in the actual slideshow mode. So I don't know whether it's better to just kind of start going through those, clicking through this one on that screen instead, if that's all right, or unshare the screen or not.
Yeah, can you see that?
Yeah, that's perfect. Yeah, we're on slide 4 now.
Yeah, apologies for that. It was fine on my screen. Technology.
Yeah, exactly. All right, thank you. Cheers.
No problem. Okay, so how do we compare to other countries? So you can see on this slide we're quite low down compared to some of our neighbours, especially in our Scandinavian Nordic countries. So this is penetration by 1,000 households. So we can see Norway, Sweden, Finland, well over 300 heat pumps per 1,000 household. In the UK, we're less than 10. So we are lagging behind. But what we've got from these countries is we've got some key lessons to learn from these countries in increasing deployment of heat pumps. And the big thing is including tight carbon emission standard in new builds. And we're seeing that with the new building regs coming in June this year. So we're on the right track, but we've got a long way to go to catch up with our neighbours in Europe. So how is that going to affect the growth of heat pumps? So as I say, Boris said 600,000 heat pumps. So this slide is a slide we produced with recommendations from the Committee on Climate Change. As I said earlier, 1 million heat pumps by 2030 if we're going to achieve our targets. But how's that's going to be made up? So we think in the with the building regs coming in this year, that the vast majority of heat pumps installed between now and 2025 will be in the new build. Okay, so in 2020, just to give you an indication of sales at the minute, it was around about 36,000 heat pumps installed. So quite low compared to gas boilers, which is about 1.7 million. However, we did predict last year that we will probably double in sales. So last year, we were around about 68,000 heat pumps. And this year, we estimate that will be around about 100,000, just over 100,000. So we are on the way to the 600,000. And if with the new building rates coming in by 2025 and the next building standard coming in, and if we're building around 250 to 300,000 homes a year, 200,000 plus of those new homes will be heat pumps, and maybe 100,000 plus 200,000 in retrofit. So that's where we're on the route to the 600,000. So it is achievable, even though we're talking low numbers at the minute. So I think it's set to double every year with a lot of the policy which is coming in place. So who's going to install all these heat pumps? So at the moment, the only way of measuring how many heat pump installers are out there is from the Micro Generator Certification Scheme, the MCS. And there's around about just over 1,000 registered companies. Obviously, some companies, those companies may have one person, some may have several people. So we estimate there's around about 3,000 to 4,000 trained installers currently. Okay, so if we're going to actually achieve this 600,000, it's important that we need to scale up the installer numbers. It's fundamental in developing in the growth rate for the heat pump market. Okay, so all heat pump members have agreed to deliver a new training course, and we all have a capacity to train over 15,000 installers a year. So we're trying to do our bit. Obviously, colleges will try and do their bit. And when we talk about new installers, that people think about new green jobs. What they don't realise is that we've already got a workforce out there with over 100,000 gas-safe installers out there, just like yourselves. So it's about retraining, upskilling those existing installers who you've all got the necessary skills. It's at the end of the day, it's just heating. It's just a different source of heating. It's training and upskilling existing installers to be able to install heat pumps as well as other heating systems. So we probably need by 2025 around about 30,000, and by 2030 to install 1 million heat pumps, we need around about 45,000 installers. So again, a challenge, but not unsurmountable. And you'll see in a little second what we're doing as an organisation to try and achieve that. So how to get trained on heat pumps and the opportunity for engineers. So at the end of last year, we launched our new training course. It really had good feedback, especially from the Energy Secretary, from Business and Energy Secretary, Fraser Kwartang, gave us a good comment. And the new heat pump course criteria is targeted at upskilling existing installers. And the course has been delivered by HPA members, and the HPA membership makes up the vast majority of heat pump manufacturers, but also the vast majority of heating manufacturers, and which make up the main boiler manufacturers. So all our members have training academies all over the country. So, and as I say, we've got the ability to train over 15 on those training academies, over 15,000 installers a year. So the capacity is there. We just need to get installers through the door. Unfortunately, we've been asking government for some sort of funding, especially for early adopters and people wanting to come in at the first stage. We'll keep trying. There's nothing at the moment. I think the training course, and as you know, manufacturers may subsidise the training. It's not so much the cost of the training; it's more time off the road. Because if you're in training, you're not getting paid. So we've notified government of that, and if we really want to kickstart this, we've asked them to maybe have some subsidy or voucher schemes for training. So there's no need to make that shift immediately. We're not about training the 100,000 straight away. Okay, we need, to say, around about 15,000 a year. As I say, you've got lots of transferable skills, and the course is targeted at those skills you've got. But there needs to be some great sense to some things that are not necessarily commonplace in the boiler industry. and that's such as heat loss calculations, room by room heat calculations, accurate sizing of the heat pump for the heat demand, and also heat pumps work on low temperature heating. So heat pumps are probably unforgiving, where maybe gas boilers are more forgiving. So there needs to be care in the design of the system, and that is something which is taken into account in a new training course. So this just gives you a little a roadmap to becoming a heat pump installer. So as I say, most plumbing and heating engineers have got the necessary skills. Most will have a minimum of level 2, level 3 in plumbing or heating or equivalent. There is a route to people who may have the necessary skill but not got the formal qualifications. And what's also been developed in conjunction with the new heat pump course is a new low temperature heating and hot water course. So that's a 2-day course. That's agnostic to heating, to heat pumps. So it's around complete heating systems. It's going back to basics in doing room by room heat loss calculations, pipe sizing, hot water cylinder sizing. So giving you the necessary skills then to move on to heat pumps. And the way we've designed the heat pump course is to have a 2-day foundation course, which takes in all aspects of heat pumps, and then a 1-day course on the actual technology you want to train on. And that could be 1 day for air source and 1 day for ground source. So I would think that most installers would do a 3-day course, which at the end of it, they would be able to install an air source heat pump, 4 days if they want to do ground source heat pumps. Doing that course then puts you on the route to certification. And at the moment, certification is through MCS. Okay, this course is approved for MCS. So by doing this course, then you can apply to become an MCS installer. MCS has recently changed to 2 categories of installer. One is an installer without design, and one is a design and install. Okay, but by taking the low temperature heating, then the heat pump course will give you the full design and install capabilities. If you don't want to do design and somebody else is going to design, you could move straight onto the heat pump course, but you wouldn't be able to design under MCS. So you still get your MCS certification, but you'd have to have a separate company, maybe a manufacturer or a separate company to do the design for you. So you have got that option. So what's happening regarding subsidies? So some of you may have heard of the renewable heat incentive. The renewable heat incentive ends the end of this month, the 31st of March. There will be no extension. And that is going to be replaced from the 1st of April by what's called the boiler upgrade scheme. And the difference between that and the renewable heat incentive, where the renewable heat incentive was paid for the renewable heat you generated and paid over several years, this is an upfront grant. So you get £5,000 for an air source and £6,000 for an air source. As an installer, you need to be an MCS installer to be able to access this scheme, and it will be the installer who applies for the voucher application. So everything is through the installer, not through the homeowner. So it's slightly different but it's a simpler process than the renewable heat incentive. What this also means is a homeowner knows up front that what they're getting. So they're getting basically £5,000, £6,000 off the install. So could help with distressed purchasers, that a decision could be made quite quickly. With RHI, there was a lot of hoops to jump through, a lot of bureaucracy that has now been taken away. So the process hopefully will be simplified. So we have got some dates here. So the 11th of April, so starts on the 1st of April, and these are dates what came out last week and typical government. The actual, if you are an MCS installer, you can apply for the account to have your account open with the boiler upgrade scheme. Ofgem will administer the boiler upgrade scheme. They administered the renewable heat incentive, and then unfortunately the date which we've complained about, the actual scheme for voucher application does not open till the 23rd of May. Okay, it does mean that you're able to install, but what we're concerned about is, would installers be confident, would homeowners be comfortable about having installs without the voucher being installed? So we've gone back to government saying that we don't think this is, the timings are good on this. So you can't apply for the voucher till the 23rd of May. They are confident that payment will be quick, up to 2 weeks, but they have said it may be slightly longer when the scheme opens. Again, this is something we've gone back with our reservations to. And what the government is expecting you to do is, if you, for example, did an install for £10,000, that you would charge the homeowner £5,000, and you would get the £5,000 voucher paid directly to you. So the payment needs to be quick, okay? Because what we've tried to say to government is that most installers are probably like yourselves, small businesses, one-man bands, where cash flow is king and prompt payment is necessary for this scheme to be successful. We had issues, maybe some of you are aware of the green grants which came out last year, where payments were not paid promptly, and the scheme collapsed. So they need to learn from the lessons from schemes of the past as well. They're just some the key dates there. So they've only just come out, 1st of April, but you can't register to the 11th of April, and it really doesn't open till the 23rd of May. So the timings aren't great. It may change, and we're lobbying government to try and get the scheme quicker and mindful of the payments, but that's the dates we've got at the minute. So moving on to the type of heat out there, and currently there's probably at the moment of the sales of heat pumps is 3 main heat pumps sold. There is other ones, but these I would say are the 3 main heat pumps sold in volume. Ground source heat pumps, air source heat pumps, which probably make up the vast majority of heat pump sales currently, probably about 80%, and exhaust air heat pumps. Okay, so I'm just going to go through the differences in each of those technologies. So air source heat pumps. So just a principle of air source operation. And if people don't know how a heat pump works, everybody's got a heat pump in the house. It's a refrigerator. The fridge in the home is just working in reverse, and that's a simple analogy. So basically, we're taking a low-grade heat, and in this case, we're taking the air outside around us, and taking that air with a fan over an evaporator, and inside that evaporator is a refrigerant. Different types of refrigerants, but a refrigerant. And what most refrigerants have in common is a very, very low boiling temperature. So that's where the low-grade heat is enough to boil the refrigerant, and the refrigerant then goes into a compressor, and a compressor compresses that gas thousands of times, and with anything you compress, especially gas, you get a very hot gas coming out, and that's the hot gas you use to heat your heating, your radiators, and your hot water. And that goes into the condenser, and that condenser is just like a heat exchanger you'd have in a gas boiler. As the refrigerant cools down, turns back into a liquid, the pressure is let off through an expansion valve, and the process starts again. Very, very simple process. So just some things with air source. One of the big things with air source is planning permission. So from 2011, the installation of a heat pump for domestic premises was considered what's called permitted development. So not needing an application for planning, provided all limits and conditions listed below are met. So when you go and go to somebody's house, you have got limitations where you're sited. So there's distances from next door's windows, from next door's boundary, from habitable rooms. You need to take into account, is it a conservation area? You can't put it at the front of the house. So quite a few conditions. The size of the heat pump is one, for example. All manufacturers fit in at the moment within those dimensions. Also sound, where you're siting it, sound, and again, all manufacturers fit into the permitted developments. But the things you need to look at when you're looking at where to site the heat pump. Once you've thought on where you're going to site the heat pump, then you do have the unit installation and the minimum distances you need to site it. And most manufacturers are around about the same, could be a few millimeters difference, but most manufacturers would recommend around about 100, 150 mil off the wall. You would need space at the side. A lot of that space at the side is for maintenance and servicing. And the main one is the space at the front. Most are a minimum meter, some could be 1.5 to 2 meters. And that's so you can get an adequate circulation of air through the heat pump. So basically the fan runs, you're taking air through the back and blowing it out at the front. So you want free air at the front. You don't want to have recycling of the same air, also heat pump will continue to cool down. Also, one thing with a heat pump is condensation. You do have condensation from a heat pump, and that's basically when it goes into defrost mode. So in winter, when the heat pump's working hard, and depending on the outside humidity, then the evaporator freezes up. You can get ice on it. So if you've been to a heat pump, you may have seen ice on the back of the heat pump. That's quite normal. And every so often, depending on the ice build-up, the unit will go what we call into defrost mode. It will defrost generally through hot gas, where it reverses, takes defrosts it off the evaporator coil, and that needs to be drained away. So you need to adequately drain it. Very similar to a condensing, so you have to adequately drain that away safely. So that could be into a drain. You could drain it into a soakaway, and again, you'd need to probably look at the manufacturer's recommendations, because most manufacturers have different ways of doing it. So, but it's another thing to actually look at when you go and survey once you know where you want to site the heat pump and you survey the house, that the condensate needs to be something to be looked at as well. So just a basic schematic of a heat pump. Okay, so an air source heat pump, hot water cylinder. So basically we're working on a Y plan. So you'd have an outdoor heat pump, you'd have two pipes into the house, a 3-port valve going to a hot water cylinder. That hot water cylinder would have to be a hot water cylinder for a heat pump, because heat pump cylinders generally have a larger coil, a larger heat surface. So it's a cylinder designed. You wouldn't generally use the existing cylinder, which is probably been with a gas boiler. If you're refurbing, you probably have to put a new boiler, a new cylinder in with a larger surface area coil, and that could go to radiators. To underfloor, you could have a mixture of systems, you could have radiators upstairs, underfloor upstairs. But again, going back to the design of the system, you would need to adequately design the system to suit the output. Radiators, we recommend maximum 50-55 degrees. The lower the better. 45, most manufacturers recommend, if we're designing it from scratch, around about 45 degrees. Lower the flow temperature with anything, more efficient. So maximum probably 50-55 degrees, but lower is preferable. Also, we have hybrid. Okay, you may have heard of that. That's where you combine a heat pump with a gas boiler. Okay, it is seen as a transitional technology, so maybe a way of transitioning away from gas boilers towards a heat pump. Okay, could be lower disruption. So you're taking a traditional boiler operation combined with an advanced heat pump technology. Very simple connections, no refrigerants. Okay, It's a monoblock system, making it fast and easy installation. If you've got an existing combination boiler, then you could put a hybrid in, use a combination boiler for the hot water, and the heating is through the heat pump, and maybe backed up with the gas boiler on the coldest day. So other things hybrids could be used for is for larger houses, hard to treat homes where larger radiators are not suitable, or insulation measures are not suitable. So they do have the place. However, we must recognise that heat pumps can work for the vast majority of homes. So if you size a heat pump adequately, most homes can be heated with a standalone heat pump. But hybrids do have the place and are seen as a benefit, as a transition as we move towards more and more heat pumps. So next one is ground source. Very simple principle of operation, exactly the same operation as the air source. The only difference this time is that instead of taking the low grade heat to boil the refrigerant from the air, we're taking it from the ground. Okay, so what we have in the ground is either a borehole, which is either drilled to 200 meters maximum, say, or pipes buried in the ground, around about 40 mil pipe. What's in there is an antifreeze. Okay, we're taking low grade heat out of the ground, which can be static around about 10, 12 degrees. That's enough to boil the refrigerant, and the principle is exactly the same as what's in an air source heat pump. The difference with a ground source and an air source is a ground source is more efficient over the year. And the reason for that is with an air source, you're using the heat pump for the heating when it's the coldest outside, and when it's colder outside, the air source is less efficient. Where with a ground source, we're taking heat from the ground, which is static all year round. So you don't see any drop off of efficiency even on the coldest day. And that's why you get higher efficiencies through a ground source heat pump. Great opportunity for ground source. The vast majority of air source, vast majority of heat pumps are air source currently, but there's a great opportunity for ground source. As I say, more cost effective than many alternative heating fuels. So it's one of the most efficient of all heating sources. If we're talking new builds, it gives you quite high scores in your SAP rating. It has a longer lifespan with an air source. It's outside in all weathers, okay, where a ground source heat pump is in the house. So a ground source can last maybe from 15 to 20 years, where an air source outside, and a ground source from 20 to 25 years plus. So slightly longer lifespan. It's quiet, okay. You haven't got a fan in it, so it's in the house, very quiet, so no noise issues with a ground source heat pump, okay. And once the ground loops, the boreholes and the ground works are done, then the actual installation side inside the house is just like any other heating system and just like the air source heat pump. Okay, so it's very simple operation for the heating side. But it does have some challenges. And the challenge is mass deployment. Okay, and one of the biggest challenges is the disruption to existing properties. So putting as you can see there, a drilling rig in an existing house, it could be quite a challenge. Okay, the biggest challenge is the high upfront costs. Okay, another one is consumer informality. They might not know about it. I think people know about air source heat pumps and the space requirement from the offset. But it does have some benefits, and benefits if the groundworks can be done in a measured way. So could be a benefit in new build if the groundworks were put in at the start of the build, seen as an infrastructure. We could move on to street by street installation of boreholes, or by or street by street access to heat from the ground. But that's probably a few years away. But this is the opportunity where mass deployment of ground source come in and is getting away with the challenges, as you see there, with high upfront costs. And the last one is exhaust air heat pumps. So again, exactly the same principle, and this is maybe a technology you're not aware of, but it's mainly in new build, but it's probably one of the most common types of heat pumps in Scandinavia. 90% of all new homes built in the Nordic countries use an exhaust air heat pump. And the reason for that is they've got high insulation levels in their homes. And as we move toward more insulation in homes, then ventilation becomes a real big requirement in homes. So what a exhaust air does is it takes the same principle as an air source heat pump, but uses the ventilation to boil the refrigerant and then discharges that outside. So it's combining the purpose of ventilation to remove stale air, supply fresh air, prevent moisture and mold growth, and use that heat to produce more heating and hot water before discharging that to the outside. That's the principle, very simple principle. And we can see the schematic. It's a package unit, so generally these are package units. They've got the hot water cylinder there, all the components, the heat pump and the ventilation module all in one. So ideal in a new build situation, very compact. And then ductwork from your wet areas, which could be your bathroom, your kitchen, utility rooms, ventilating those rooms, taking that through the heat pump. Before that stale air is discharged, you're using that air to actually produce heating and hot water for your home. So very simple method of combining it. One of the things with an exhaust heat pump is that it's quite a small output. So again, it's probably not suitable for retrofit. It's more for new build, where you've got a highly insulated home, probably no more than 4 and 5 kilowatts, which we will see with the new building regs coming in the future. So this is probably technology we're going to see more and more in new build applications as the new building regs comes in over the next year. And I think that's it. That's questions. Hopefully that's generated lots of questions. I apologize with the technical with my presentation. I'll hand back now to Jude. Hopefully we've got lots of questions and I'll try and answer them.
Brilliant. Well, thank you for that, Phil. That was, very insightful, and we do have some questions filling through. So please do continue to send them in as well if there's anything else you want to ask Phil. But I guess we'll kind of start slowly making our way through what we've got already. So first question that we've got is basically kind of going back to something you mentioned early on about oil and LPG installations being phased out by 2026. We've got a question asking, is that just new installations, or does that involve the existing installations as well?
No, that'll be new installation. So it'll be somebody who's wanting to install a heating system from new, or wanting to replace existing oil or LPG boilers. There's no policy in place. It's just an ambition at the minute. There's no policy in place to actually what this will look like, but there will be a consultation this year, and you will have opportunity to feed into that, how that will look like. LPG and fuel oil are high carbon fuels compared to natural gas. And obviously now with the price of oil, then it would make sense to move to low carbon technologies. And hopefully by 2026, we'll have a continuated boiler upgrade scheme. So hopefully the 5,000, 6,000 grant will be enough to be the difference between a new oil boiler system and heat pump.
Great, perfect. No, that's great. Thank you. Next kind of question, just kind of interpret it, I think, asking about basically low temperature heat systems, and obviously how that kind of works with kind of Legionella, given, basically how will that kind of work kind of going forwards, really?
Okay, so Legionella is mainly on the hot water and hot water storage. So you should store hot water at a minimum of 60 degrees. And I think the water bylaws that it needs to reach a tap to a minimum of 50 degrees. So all heat pump systems achieve that now. Okay, Most refrigerants now within heat pumps are well over 65 degrees. So heat pumps can heat hot water to 60 degrees. So there shouldn't be any issues with Legionella protection on heat pumps. Older systems, which probably only heated water to 55 degrees, used a top-up of an electrical immersion every day or every week to actually sanitize the hot water. So that's how it was done historically. But with the advent of new refrigerants, most heat pumps, especially heat pumps coming in now, which all new ones, heat the hot water to well over 60 degrees. Most heat pumps can achieve well over 70 degrees.
Great. Perfect. No, that's an excellent answer. Kind of next question is kind of to do with disruption, really involved with heat pumps. So I'll just kind of verbatim say what the question says. To be effective, would a heat pump require the entire existing water pipework system to be replaced together with large radiators due to lower temperature water flow? If so, surely this means taking up the existing floor coverings and floor screed at huge cost and disruption. Kind of what's your perspective on that, Phil?
Yeah, it's an hard one to surmount, because there hasn't been, and we've asked the government to really do some work on this. We estimate that 16% of homes already built probably don't need any upgrade at all, okay, with their existing radiators, because most radiators already are oversized. Probably another 30% will need an upgrade, maybe 2 or 3 radiators, maybe £500, say, and 60% would probably need over £1,000. So this is the reason when you go into a house, you need to do a full room by room heat loss calculation to see. What we used to do, and this is probably with MCS regulations coming in, and sometimes regulations are good, but it does overkill sometimes. And this is the reason why at the moment with the regulations that we go into houses and we're probably taking out all the radiators and replacing them, which adds extra cost. Where hopefully with the new boiler upgrade scheme, we'd be able to do it probably a bit more systematic. He may be saying to the customer, right, I've done this calculation, it all looks right. Let's get the heat pump in, and if some rooms aren't getting up to temperature, then maybe put a bigger radiator later down the line. And that's how we used to do it here. The MCS doesn't allow you to do that.
Okay, great. Next question is around the cost of installer training. So kind of, are there any kind of costs, I guess, to kind of look out for, I guess, at this stage, really, Phil?
Yeah, I mean, cost is a different one. I mean, if I say heat pump training, if I look through a college, I would say heat pump training is probably around about £450. If you're doing it through manufacturers, as you know, some manufacturers do incentives. Maybe you go and do the training and you get that money back if you buy heat pumps off them. So there is ways around it. As I say, I don't think it's so much the cost of the training. It's more probably time off the road. You're probably going to lose more on that. And that's where we said to government, maybe as an incentive, to get installers, because we need installers. If we're going to reach that target, we need to train more and more installers. So, and we need to do that fast. So giving some sort of incentive to the early adopters, to give them some sort of financial package to train, would be a great incentive to kickstart this industry.
Absolutely. Yeah, let's hope they do so. So kind of next question was, can you still get boiler upgrade scheme funding if you use a hybrid?
No.
Short and sweet. All right, fair enough. Cheers. Next kind of question. He's wondering about the PowerPoint presentation. Is it possible to be shared after the fact, Phil? Or,
yeah, that's no problem. I can share it with you, Joe, or
yeah,
whichever
great.
you want to do it. Yeah.
In that case, we can probably upload it to the HPP website and have it accessible along with the video. So yeah, we'll look to do that after the fact. So thank you for that question. Great. Question I've got here, given the financial outlay to convert to a heat pump system, what is the selling point to convert, given the conversion to hydrogen potentially being a cheaper option, this person says?
So I didn't catch that, Joe.
Oh, sorry. He's wondering what the financial outlay basically of converting to a heat pump system is kind of overall compared against, for instance, a hydrogen situation where theoretically it could be cheaper.
Theoretically, it could be, but with hydrogen, it is all theoretical because
Yes.
we don't have hydrogen. So
Mm.
we don't know what hydrogen is going to be in the future, okay? And the technology isn't here. But again, what I would like to see, and I think, and it doesn't matter if it's hydrogen, biomass, heat pumps, I think as a heating industry, I think we should be moving to low temperature heating anyway. Okay, I mean, we've had condensing boilers since 2006. Okay, we had an opportunity. Most condensing boilers do not condense. They're running at 70 degrees plus. So it makes sense to move towards low temperature heating. It makes any system efficient, and hydrogen is going to be more expensive than natural gas because of the way it's produced. So isn't it better that an hydrogen boiler is run at its most efficient as well? And that's the way I would see it.
Great.
I mean, just adding to that, and the government in the heat and building strategy, the government recognises that the installation of heat pumps is more than a gas boiler now, and the running costs could be slightly more as well, how you look at it. So what they have committed to within the heat and building strategy is to see parity across running costs and installation costs in the next 10 years. So the government has committed to that. And at the moment, if you look at electricity, most of the green levies are placed on electric, not on gas. Okay, so they recognise that as well, and it's how we move, how we transition away from those subsidies as well.
Makes a lot of sense. Great, perfect. Thank you. Next question. You're probably not an expert on the subject, but I'll get your perspective on it anyway, or at least what you can do. I've got a question asking: will the national grid be able to cope with the extra demand for electricity if everyone gets heat pumps?
Yeah, it's an interesting one, and it's one which is always comes up from the incumbents. Okay, and they always show a picture of the gas demand on the coldest day. Okay, yes, but what we need to remember, and I've said this for a long while, we're moving towards electric cars. So every house is going to have to electric charger in. So we're going to have to upgrade anyway. So basically, electric EV charging is a Trojan horse of heat pumps. The next thing is flexibility of the grid, and this is the exciting part of heat pumps, is that heat pumps have this technology to become smart. So we can phase the grid, turn heat pumps off slightly. We can use the house as its own storage. When the wind's blowing, you can heat the house up, heat your water up, store it. So there's a lot of flexibility with the ability with heat pumps in the future, and I think that's a real exciting part of heat pumps for the future. So I don't see it as a barrier, and we got to remember we're not coming to 1 million heat pumps overnight. It's going to be over the next 10 to 15 years, so we still have got time to get the grid ready for that, and we're going to have that grid ready by 2035 anyway, when fossil fuel vehicles are banned.
Absolutely, yeah. Time is on our side, but also not on our side, I guess, in some ways, isn't it? So no, that's great. Question here, kind of, is there an expectation that heating engineers kind of almost become refrigeration engineers, and obviously become F-gas certified in regards to heat pumps?
I can't see that. I mean, if you look at in Europe, some heating installers are also refrigeration as well, and that tends to be in countries where they've got warmer summers, so they're doing air conditioning as well as plumbing. Most installers in the UK are not refrigeration engineers, and that's why most heat pumps in the UK are what we call monoblock heat pumps. So the refrigerant is just like a fridge; it's in the heat, but you don't need to touch it. So if you're installing heat pumps, then there's no need to be an F-gas. The only time you have to do it would be an F-gas if you're actually repairing or breaking into the refrigeration circuit. So maybe you need to look at if you want to get into servicing and repairs of heat pumps later down the line. But to install heat pumps at the moment, you don't need to be F-gas.
Great, perfect. Cool. So next question I will move on to, as I've just missed off it. So it's a bit more of a generic one, so I'm not entirely sure of the entire kind of coverage of it, but basically a question asking kind of, does pipe work need to be upgraded generally as well, I guess, assume for retrofit situations.
Yeah, again, it's one of those, each property will be different. It's like the radiator question. I would think that the vast majority will be minimal. Yes, you probably pipe work around from the heat pump to the cylinder or the airing cupboard with a 3-point valve. You may have to go from 22 to 28. That may be a possibility, but again, it depends on the heat output. You only tend to go to 28 mil above 10 kilowatts. Everything below that is around 22 mil. There's also issues come up, and that again gets brought up with incumbents with microbore pipe work. Again, we feel that most properties are suitable, who've already got micro are suitable, especially with the plastic type system. If we're going back to the 70s where it's 8 mil, then that probably wants ripping out anyway. But if we look at new build over the last 20 years, which has been probably plastic 10 mil, most of those are suitable, because most of those houses probably don't have a heat load more than 7 kilowatts anyway.
Great, perfect. So kind of next question, it's to do with the EPC ratings and heat pumps. It's not something I've come across personally, so I'm not sure whether you have done as well, Phil, if you've seen it. Basically, the question is around, apparently some people who've installed heat pumps have seen their EPC rating go down.
That is correct. Yeah,
okay,
it's not good. It's government know about it. It is set to change. It is historic. We've been fighting that old chestnut for quite a long while. It's not good, and the government has committed to try and get most homes EPC 3 and above, a C and above. So if we're going to achieve that, we need to change that with an EPC. So it's a recognised issue, but it hopefully now it looks like it is going to be rectified, especially now with the new building regs coming out. So we're going to have to upgrade SAP to accommodate the new building regs.
Great, excellent news in that case. Right, so kind of question about basically exterior pipe work. Kind of, does the water need glycol to prevent freezing kind of when the system isn't in use?
Yeah, and another one, it's probably manufacturer specific. Okay, so some manufacturers don't recommend glycols within the system. They have other types of protection. Some do. For example, some air source are manufactured and designed for Nordic conditions. So they're designed down to -25. And some of those manufacturers don't recommend antifreeze. So it's manufacturer specific. So it's probably a question when you choose a heat pump manufacturer, that's towards that manufacturer. So it's specific to the manufacturer.
Okay, great. Probably a kind of how long is a piece of string question, to be honest, to an extent, but kind of what is the cost to install in kind of retrofit situations, heat pumps typically?
Again, it's a difficult one, because again, you have headlines from like the Daily Mail and the Daily saying it's 25. It's all different. I would like to see, and you've probably seen Octopus saying this as well. Okay, I would like to see installations for a typical 8 kilowatt house around about 10 to 11,000 pound. Maybe we can get it down to 7,000 pound. I don't know, but at least so then if you take in, and this is where Octopus say, if you take the 5,000 pound, then you're getting towards the cost of say a gas boiler, or just more than a gas boiler. Okay. If you look at most systems which are well over that, 16, 17, then they're generally part of a fuller retrofit, because what we've seen in the heat pump industry over the last probably 10 years, most heat pumps have gone into probably more larger affluent type people, not in the mass housing. So once we get into mass housing, then I think we're going to see a more sensible cost of heat pumps. And obviously more installers makes competition. Obviously, if more heat pumps manufacturers, as we know, anything which increases in sales, the costs reduce. So this is something we've got to have a reduction in price, not only equipment, but in install costs over time. And as I said earlier, that is something the government wants to see over time, the parity. But what we don't want to see is a reduction in quality of standards. That's the important one.
Yeah, exactly. I guess that's always the danger when you kind of enter the mass market a little bit more, isn't it? So,
yeah, and we see bad installs on gas boilers. So and we'll probably have a fair share on the heat pumps. And it's important that standards are kept, because, as I said at the start, heat pumps are unforgiving. Okay, if you design it wrong, the homeowner is going to know about it, either that in comfort levels or in high running costs. You're very forgiving with a gas boiler. You just turn it up. So these are the things we need to be careful of, and I think all manufacturers are committed to making sure. And most manufacturers, it's their name on the equipment, so they want to make sure it goes in correctly.
Great, perfect. Okay, so just to say, we've got about 5 minutes left, so I'll try to get through as many remaining questions as we can. Obviously, if there's any particularly pressing ones, then do use the upvote, and that will kind of head to the top of the list, and we can kind of make sure we get those done. But yeah, the next one I've got in front of me is basically, are you aware of kind of any plans to kind of create kind of designer training for, say, local authority kind of engineering kind of contractor tenders, kind of, I guess, kind of look a little bit more training rather than just, I guess, kind of the one-off installer, to kind of look more at kind of those bigger local authority schemes?
Yeah, I mean, we've got the heat upskill training. The next one is obviously apprenticeships. We've got the low temperature and hot water course, which is more of a design course. We are looking at more CPD courses, like I say, maybe for more consultants and designers. And that's all something we've got planned. Our main challenge was to have the course. The most important was to get the upskilling course out. But great opportunities as the market grows. There needs to be lots of different courses for different people within this field.
Great. Yeah, perfect. Question about, on an average semi-detached house, will the flow and return pipes to the rads need increasing in diameter for a heat pump install?
Yeah, that's a similar question to we said last time. It depends on the system. As I say, I would think the vast majority of hoses would need some sort of pipe work change, but minimal. Okay, some may need larger changes. It all depends each house, but I would say the vast majority of houses would be minimal pipe work changes. As I say, probably from the heat pump to the hot water cylinder, where the 3-port valve in the hot water cylinder is.
Great. Okay. Yeah, no worries. So another lovely technical question for you. What is the energy gain of the 3 types of heat pumps that obviously you spoke about in your presentation? It's just popped out on my way. Meaning, if you put 1 kilowatt of electrical energy into like, how many kilowatts of heat do you get delivered into the house? Is that something you're able to answer?
Yeah, no, that's fine. That's fine. I mean, it's like cars. It's miles per gallon. Okay. Yeah. We've got the COP, which is measured at a set. Then we have the seasonal. And at the moment on heat pumps, we have an energy label. At the moment, European standard ERP. So a air source can be up to, some of the new ones coming out can be up to 5. Okay. Ground source can be over 5. Okay. In reality, you're probably not going to see that in design, but I would say a correctly designed system, a seasonal performance of an air should easily be 3 and above, and a ground source should be easily 4 and above. An exhauster, again, should be, because it's more of an air source, and a ground source would probably be 3 and above. Okay.
Great, perfect. How long does it take to get an MCS accreditation, would you say, on average?
Well, one of the principles of MCS is to try and simplify it. And the problem with MCS, it was an act of parliament through RHI. So it was set up initially more around consumer protection than probably design. And what we've had over the last few years is more going onto the design element, which is important. So consumer protection is important as well. So there has been a lot of work. So I think once boiler upgrade scheme starts and RHI finishes, then we're going to see more of a simplified scheme to join. The big thing is now it's recognised, if you do the training course, you can join MCS straight away. The problem with the moment with MCS is that they don't actually do the certification. They rely on certification bodies. So it's how quick that certification body can do the paperwork. But if you've already done the training, it should be quite quick, I would say. It depends on how quickly they can come and do the audit.
Yeah. Okay. Brilliant. Kind of, there's a link, kind of MCS question here as well. It's about, I assume, kind of similarly to how obviously with gas boilers, you need to kind of retrain every few years. Is there kind of, in regards to heat pumps and MCS accreditation that how often would you kind of need to retrain, or is there a system set up like that?
Well, yeah, there may be, and because I would say training is, if you do a proper qualification, it's not evergreen. So you might see some of these heat pump courses. You may, just like the G3 courses, you may have to do a review every 5 years, for example.
Okay, great. Perfect. Yeah, no, that makes a lot of sense. Okay, well, we've actually hit 5:30 now, so I think we'll probably have to wrap up now. So thank you so much, Phil, for great presentation, and also running the gauntlet of questions that have been thrown at you. I'm sorry we couldn't get through everyone's questions, but obviously, I think hopefully the subject area has been largely explained for a lot of you, and as mentioned, we're going to be uploading the recording of this session to the HVP YouTube channel and the HVP website. So thanks again, Phil, and thanks everyone else for joining us, and we'll get that all sorted out soon. All right, thanks very much.
Thank you. Have a great evening, everybody. Thank you for listening. Bye bye.
Cheers. Bye.